So good morning to everyone present, all the participants, Dr. Nirmal sir and Ringanam sir. So good morning to every one of you. I welcome every one of you for today's session. So first session will be taken by Dr. Nirmal Kumar sir. So well-known person in this zone in our field of civil engineering academic field. I will give you an introduction about Dr. Nirmal Kumar sir. Dr. K. Nirmal Kumar obtained his BE Civil Engineering from the Bharathiar University in 2000 and he has completed ME Structural Engineering from the Anna University, Chennai in the year 2001 and PhD in Civil Engineering from the Anna University, Chennai in the year 2009. So he has completed his MBA from Periyar University in 2013 and also he has completed his MA Psychology from the Periyar University in 2018. At present, he is working as a professor in civil engineering in Konga Engineering College, Perundurai, Erode district. He was recipient of 11 awards, of which few significant awards are IEI Young Engineers Award from the Institution of Engineers, India, Kolkata, Career Award for Young Teachers with a cash benefit of 5.48 lakhs from AICT New Delhi, PK Das Memorial Best Faculty Award with a cash award of rupees 10,000 from Nehru Group of Institutions, Coimbatore. So after he had published 127 technical publications in various reputed international and national journals and conferences in diversified areas. He had published various chapters in the textbook Advances in Civil Engineering. He is currently supervising 11 PhD research scholars. At present, he is a reviewer of 27 international and national journals, 4 national conferences, 7 international conferences, and 6 textbooks of Pearson India Education and McGraw-Hill Education. He had completed 3 research and development projects funded by UGC, AICTE, and DST to a total amount of rupees 17.08 lakhs. He had associated in several testing and consultancy activities in the field of surveying and concrete to a tune of 11.59 lakhs. He had visited different countries, say Austria, Belgium, Brazil, Cambodia, and France, Germany, Hong Kong, Hungary, Indonesia, Malaysia, Muscat, Philippines, Singapore, Slovakia, Sri Lanka, Switzerland, Thailand, United Arab Emirates, United States of America, Uzbekistan, and Vietnam, etc. In addition to that, he had chaired and delivered the keynote and invited lectures in about 128 occasions at various levels in the program sponsored by AICTE, CSIR, DST, and MOES, and Anna University also. He had chaired a technical session in an international conference organized by World Academy of Science, Engineering and Technology at New York, USA on 4th June 2015. He had served as an expert member of faculty selections board for various institutions and a pivotal role as expert member of PhD oral examination board of Anna University, Chennai. Academic Council member, editor of 3 journals, JACCT, JACE, and JBC. He had organized 36 programs so far, such as conferences, exhibitions, national seminars, workshops, competitions, etc., funded by various government professional bodies, etc. He is life member of ISTE, ICA, ITS, Chartered Engineers India, ISDS, IAE, ECS, and ISQEMA and IPHE. He is a fellow in Institution of Engineers, International Society for Research and Development, and Institute of Research Engineers and Doctors. So with this introduction, so he is from this introduction, you all know about his excellency in the field of civil engineering. As a very good academician, as a national wise, is a best one of the best academics available national wise. So with this introduction, I like to hand over the session to Mr. Dr. Nirmal Kumar. Dr. Nirmal Kumar, sir, please.
Thank you, sir.
Thank you, sir. And continue.
Thank you, sir. Thank you for giving me the introduction, sir. And also at the outset, first I would like to thank sir and the other organizer for giving me this wonderful opportunity to discuss about this topic of e-waste in concrete. And sir, can I start the presentation, sir?
Okay, sir, you start the presentation now.
Sir, is the screen visible, sir? Sir, is the screen visible?
Yes, sir.
Yes,
Visible.
Yeah, thank you. Thank you, sir. So, our today's topic, a brief review on e-waste in advanced construction technology. So, I hope you know now this e-waste, it is a very big major issue in disposing this e-waste. So now we are finding some alternative method to use this e-waste in our construction. And in this presentation, I'm going to give you few reviews and case studies where they had used this e-waste in the construction. And for your information, if any of you want to do the research, I think this is the best upcoming area. And now the research has been started slowly in these emerging areas, and quite possibly within a couple of years or within a couple of decades, this will become a big boon to the entire construction industry, not only to the entire construction industry, to the entire society in reducing this problem of this e-waste. So I hope let me give you an additional information. So we are celebrating the International E-Waste Day on October 14. I hope based on this thing itself, I hope you know how this e-waste is a very important and a prominent factor which influences our day-to-day life. Okay, because of this e-waste over a period of time. Okay, while in the discussion, I'll be showing you a lot of things where we are having these, where we are generating the e-waste. Okay, so this is based on this only the international committee. They are celebrating the International E-Waste Day, that is on October 14th. And in India, lot of measures. Okay, see, if you see this, in India, lot of measures and lot of funds are being invested or being given to the research organization to how we can effectively utilize this e-waste. So nowadays, I hope many competitions are being conducted or organized by the government of India, and not only by the government of India, even the many public sectors and even the many NGOs, non-government organizations, they are conducting many events to promulgate the awareness about this e-waste. Okay, so this is all about this e-waste, a small introduction about the e-waste. So today, highlight of my presentation. So first, prerequisites. So prerequisites, because I think many people are faculty, and I hope many people will be in the other forms apart from concrete technology. Many people will be in few people will be in the structural engineering category, and few people will be in the environmental engineering category, and few people will be in the water resources discipline. Okay, so just to recall the things, let me give you a few prerequisites so that it will be easy for you to easily understand and grasp what I am telling in the forthcoming reviews. And next, we are going to see what is meant by e-waste. Then we are going to see how the e-waste is formed. Then the scenario of e-waste disposal, both in the international perspective as well as in the national perspective. Then we are going to discuss about, or we are going to see what are all the various methods available for the disposal of e-waste. Then we are going to discuss about the effects of e-waste. Then we are going to see the reuse of e-waste. Then recycling of electronic waste, and also few observations and reviews. And this observation and reviews, I hope you people, if you are anybody want to do research in the field of, if you want to start your research career, then you will be having some a little bit information from the last one. So let us see the prerequisites. So all the prerequisites are a very simple terminology, but in addition to, I mean, just in order to brush up the thing, I'm just giving you the few prerequisites. So first one, compressive strength. I hope you know compressive strength means just we will give the loads, and when compressing the thing, we will be seeing what is the strength of the particular material. Mostly we will be using the cube. Okay, mostly we will be using the concrete cube. Okay, and in compression, the size, it will be reduced. In compression, the in the compression strength, the size will be reduced. Okay, then coming to the next one, you may wonder why I am giving you all these basics. Okay, because in the latter part, we are going to discuss about many reviews and case studies and information. There I'll be giving you, I'll be giving you the values. Okay, so that if you are a little bit brushing up the things, it will be easy for you to understand in those areas. Then coming to the second one, it is the tensile strength. Okay, coming to the second one, it is the tensile strength. So in tensile strength, it is opposite to that of the compressive strength. In compression, we will be pressing the thing. In tension, we will be expanding the thing. Okay, in the two different directions, we will be expanding the thing. Okay, so this is in resistance to lengthwise stress. This is tensile strength. It is the resistance to lengthwise stress. Okay, and then comes the flexural strength. Okay, then comes the flexural strength. In the flexural strength, we will be conducting this flexural strength on the beams. We will be conducting the flexural strength on the beams. When we give the load, okay, it will be the entire beam. It will be failed by a slow bending. Okay, it will not be a sudden one. It will be failed by slow bending. And at this juncture, I want to say, I hope all you know. Okay, let me ask you a simple question. I think, so concrete is brittle material or ductile material? Anybody, please?
Brittle, sir.
Brittle material. Sir, one more small thing, sir. Whether the failure of concrete, is it sudden or it takes place in a gradual mode, sir? Anybody, sir? Sir, we can have some interaction, sir, so that it will be easy. I mean, it will be a lively one. How about the failure of a concrete structure, sir?
Sir, sudden in case of plain semi concrete.
Sir, come again, sir. I couldn't able
Sudden
to get.
in the case of PCC.
Yeah, sudden. Yeah, in PCC, sudden. Okay, sir. Then in RCC, sir.
It takes time.
Okay, sir. And I know the reason why in PCC it is sudden and in RCC it is taking some time, gradual time, sir.
Tensile strength of the concrete. It's weak.
Okay, tensile strength of the concrete. Which is imparting the tensile strength to the concrete, sir?
Sir, which one?
Yeah, I think one of the participant has given the answer. Okay, sir. Just you see. Yeah, I will. Arish Kumar, sir, I will share it, sir, just to have some interaction. Don't. I mean. I stopped presenting the things, sir. See, sir, in concrete, okay, as Sendil Kumar sir told, PCC will not be having the reinforcement bar. Okay, in PCC will not be having the reinforcement bar, and it immediately fails. Okay, even in this flexural strength, when we conduct the flexural strength without using the RCC, the failure will be sudden. Whereas if you take the beam, whereas if you take the RCC beam, okay, what it will happen is first there will be some bending will be there, then we'll be having the crack will be there, then after the crack it will slowly gradually deteriorate, and finally we'll be having the failure. Okay, see, in flexural strength, okay, this our e-waste, it plays a major role in this flexural strength, because our few of the e-waste, it is having the chemical property to corrode the reinforcement bar embedded in the concrete. Okay, so that particular area we have to be careful, sir. Sir, is presentation in the full screen, sir? Ever, sir?
Sir, good morning, sir. Can you put the full screen mode so that?
Now I had given in full screen mode, sir. Is it okay, sir?
Okay, sir. Okay.
Okay, sir. So next one, it is flexural strength. Okay, so here this flexural strength, because we have to take care of this flexural strength little bit, because we are having a direct effect of the e-waste on this flexural strength. Then comes the water cement ratio. I hope you know. So this is the ratio between the water to the cement. Usually we'll be having 0.4 up to 0.35 to 0.4. It will be easily workable. And after that, what we will do, we will going for some super plasticizers or some kind of admixtures. And mostly this water cement ratio, since our e-waste, its specific gravity is a little bit different from that of the conventional coarse aggregate and the fine aggregate. So here this water cement ratio, it has to be a little bit adjusted with pertaining to using this e-waste. Then comes the admixture. I hope you know admixture. It is nothing but the chemical or both admixture. It is available both the natural admixture as well as the chemical admixtures. Because this admixtures, it will increase the property of the all the things. It will improve the property of the cement. Sometimes it will be improve the property of the coarse aggregate. It will be improving the property of the fine aggregate. Okay, so this admixture, because since our e-waste, okay, since our e-waste, it is having a lot of special characteristics, or we can say the special property. Sometimes these e-waste, what it will do, it will go and have some reaction with the existing thing. Okay, so to counteract all those things, we have to add some kind of admixture. And for your information, choosing the admixture, it is a biggest challenge. Choosing the admixture, it is a biggest challenge. Let me take a couple of minutes just to tell you how challenge it was. Actually, my research, my PhD work, it is on this studies on the suitability of industrial effluent for concrete. What I did is industrial effluent. Instead of using the water, I used the tanner effluent and textile effluent. Okay, so I hope you know the properties of the tannery water. It will be having a lot of unwanted characteristics which is against the concrete. Okay, so to counteract those unwanted characteristics, okay, what we did is we choose the admixture. Just for choosing the admixture, it takes around 1.5 years. Just if you see, I had given it in just 2 lines. I had given it in my thesis. Just I had given it in 2 lines. That is 2.5% of concur and 2% of calcium nitrate. Okay, just this is the finding out of the 1.5 years. Just to find out this composition level of the admixture, it takes around 1.5 years. 1.5 years fully we have dedicated just to determine the admixture. The same is the case for this e-waste also. Okay, even if you go for the e-waste, okay, even if anybody if anybody wants to do research in this e-waste, okay, this choosing an admixture, it plays an pivotal role in this research work. Okay, so that is the importance of the admixture. Then comes the workability. Yes, of course, we will be actually one of my UG project student. They did project based on the e-waste only. So it was very difficult for them to have the workability. It was very difficult for them to have the better workability. Often we encountered with the honeycombness, often we encountered with the segregation. Okay, sometimes if you go for superplasticization, sometimes we are encountered with this segregation. Okay, and moreover, we are not having a proper in IS 10262. We are having the design mix, but we are not having the design mix pertaining to usage of this e-waste. Okay, so it was a little bit a big challenge. Okay, so here to have the better workability, to have at least the nominal workability without having the segregation, bleeding, honeycombness. Okay, so we have to be very, very careful in choosing the workability, and in also while to have this at least a normal workability, just the amount of SP, the amount of admixture that we are going to add, it should be precisely calculated. Even if it is a little bit excess, we encountered the problem of segregation, we encountered the problem of bleeding. If it is not workable, we encountered the problem of honeycombness. Okay, these are all the biggest challenges. Okay, we faced in this workability. Then coming to the durability, yes, of course, we had seen all the basic phenomena, but if you go for the durability, okay, always we have to see the durability of our concrete. Okay, that is the very must thing. Okay, so here this durability, okay, it is we can say a lot of parameters involved in this durability, like chemical attack, then acid attack, then sulfate attack, then leaching. Okay, so all these things comes under this durability aspects. Durability of the concrete, it is comprised of even the weathering action. Okay, just I had mentioned only few things: chemical attack and operation. Apart from that, we are having sulfate attack, we are having acid attack, we are having leaching. In leaching, we are having two things. One is leaching of chloride, another one is leaching of sulfate. Okay, so these are all the various aspects. So let me ask you, let us have some interaction so that it will not be a monotonous one. Sir, it's an open question, sir. Just to have an interaction, I'm asking the question. I'm not checking or I'm not keeping the examination. Just to have an interaction, I am asking the question, sir. What is meant by leaching, sir? Anybody, sir? Anybody, sir? What is meant by leaching? Anybody, sir?
Sorry, extrusion of water from concrete.
Okay, sir. Just water or anything else, sir?
That is water with cement paste.
Okay, sir. It is not moisture, sir. Anybody, sir? Leaching. Yes, Naga Bhargavi, Sarikonda, sir. Any idea about leaching, sir?
So when it is subjected to long-term contact with water, leaching occurs.
Yeah. What exactly it happens, madam? Yes, leaching occurs in long-term contact. What it exactly happens in the process of leaching, madam?
Exactly, I don't know the process, sir. But
Hello, sir.
Leaching
Am I
happened
audible?
due to. Hello.
Yeah, tell me, madam. Monica, madam, tell me.
Leaching is happened in the wasted from the wasted which we are dumping, which are used in dumping, so that the
Exactly.
water is
Exactly, madam.
so.
Exactly, madam. Madam, in leaching, what are all the main parameters that in leaching we are studying, madam? Any idea? Monica, madam, your
Yes,
answer is
okay. In a parameter, we are wastage, solid waste management. It is happened. For example, domestic waste, industrial waste, domestic waste which are dumped in a site, then the leaching process is happen at a long time, and the leaching is affect the water level also, and it is very dangerous to the human health.
okay, madam. One more small discussion, madam. Whether when we use this e-waste in concrete and once if we break this, I mean, if we dismantle the structure and if we put on the land, okay, will there be any problem, madam, in your in your point of view?
I think I don't know actually the answer.
Okay, madam. Okay, sir. Sir, actually, in durability, because always this durability, we will, for whatever the structure, whatever the experimental work we are doing, whatever the things we are doing, we have to have it in long term. We have to see what it will happen in the long term context. Okay, sir. Whatever the experiment, even this main thing many people will not I think only in few countries, only in the developed countries, what they used to do in western countries, if you see the research work that is taking place in states or taking place in the western world, what they used to do, whatever the research results they are getting, they will go for the durability, whether after 50 years or after 100 years after the lifetime of the structure, if we dismantle the structure and if we put it on some I mean soil, or if we dump it in some dump yard, okay, so will there be any kind of this leaching? Okay, so this durability studies, leaching plays a vital role in this thing. And for your informations, okay, just these are all value added informations. Leaching of sulfate and leaching of chloride, okay, leaching of sulfate and leaching of chloride, these two things are highly toxic substance to the soil characteristics. These two things are highly toxic, leaching of sulfate and leaching of chloride, okay. Even if you see in the most developed countries, before the, now we are having the e-waste. Before the invent of the e-waste, before the coming of e-waste, we had a lot of even in Saudi countries, even in Dubai, even in Saudi countries, what they did is they used the water obtained from the, I mean, they used the water, that residue that is coming from the petroleum industry in the concrete. Okay, they did the research, they did the research work, and they showed the results was good, and they proved it is a good. But the Western country, they didn't agree this research, because they, what they did is we want to know what is the leaching property and what is the durability of this particular structure. And then once again these Saudi peoples, they once again went for the research work, and they ultimately find there was some leaching problem. So to counteract the leaching problem that is coming after 100 years or 150 years, okay, they now itself they studied the leaching problem, and they made many research to counteract, I mean, to study and to know how to counteract the problem of this leachability. Okay, and now they had find the solution. And why I am telling all this value added information, durability, it plays a vital role in all the concrete new areas of concrete. So now let us go to the presentation. Okay, so this durability, the ability of concrete to resist the weathering action, chemical attack, acid attack, sulfate attack, etc., while maintaining the desired engineering properties. And they had given the factors. So you see the factor. So cement content, no problem. Then comes the aggregate quality. So here, if you see the aggregate quality, our e-waste. Okay, our e-waste. In the coming slides, we'll be seeing what are all the chemical composition of those e-waste. Okay, at that particular point, you will know the importance of all these things. Okay, so aggregate quality plays a vital role in the durability. As usual, water quality, then compaction. Yes, sir. The very important factor when we use these e-waste as a replacement to the either with the coarse aggregate or with the fine aggregate. Okay, this compaction, it is a little bit a big issue. Then comes the curing period. Obviously, the curing period, it will be a little bit vary. But as of what we did the research work, we had cured it for just 28 days as usual. Then permeability, I hope you know it is the ability of the concrete to allow the water to pass through it. Then moisture content and the temperature. So all these are all the important factors. And if you see all these parameters, all these things, which influences the durability, it is having having a direct relationship with our e-waste. So we have to know all this information. Then permeability, it is the measure of amount of water that passes through the concrete. Then compaction, as I have told you earlier, so the compaction, it should be a better one if both the things are there. Okay, sometimes if it is not compacted also, we will be having the honeycomb structure. Okay, so here this e-waste, sometimes we face the problem of the compaction also. And here this this compaction usually we will be using with the help of the compacting rod. And if possible, if you are doing the research work with the help of the e-waste, if we are having the vibrator, it is a better one. So we used in the vibrator. Then honeycomb paints, due to the low water cement ratio, we'll be having the honeycombness. We'll be having it will not be even one. Okay, this structure, it will not be evenly one. Okay, we'll be having a small breakage in the concrete, that is known as the honeycomb. Then comes the concrete segregation. As I have told you earlier, since the workability, it is a little bit challenging issue in our while using this e-waste. Okay, so sometimes if we go for SP, okay, if little bit more amount of SP means, then also we'll be having the segregation and bleeding. Both these problems are often we will encounter while doing the trial mixes. Okay, while doing the trial mixes, we will be observing this both the segregation and the bleeding. And exclusively in our e-waste, because since its specific gravity is a little bit different from the other coarse aggregate, we encounter this problem of segregation and bleeding. Sometimes if due to low water cement ratio, we encounter the problem of honeycombness. So everything, I think usually in few of the concrete, either we will be having the problem of honeycombness or segregation, but here in the trial mix we faced both these problems. We encountered both these issues. Okay, now let us, I think with this, I think these are all the important prerequisites. Okay, because just to brush up the things I had given you. Okay, the main thing, once again, I let me give you one more thing. This particular durability. Okay, always when you are doing the research, just to be very careful with the durability. Whatever the things, whether you are adding some admixtures to counteract some encountered difficulty. Okay, so please have it in mind. You have to have the durability. Why I am telling this is, even if you are doing the research, if you are submitting the paper to a very good journal, if you are submitting a paper to an elsewhere journal, there what they used to do is, those peoples, they will go for how the durability it is there. Okay, they will see the long term. Okay, so we have to take into account this durability while doing the research. Okay, sir. If there is a doubt, you can ask me. Shall I proceed, sir? Sir, any queries for anybody? The prerequisites, sir?
No, sir. No, sir.
Okay, sir.
Sir, request to make a slideshow, sir, because the screen is little small.
Sir, now, sir? Just you tell me now, sir.
Actually, in the format, sir, just press F5.
Sir, now, sir, please check it, sir.
Now also it is in the same view.
Smaller, sir.
Sir, it's not in the slide. Not in the slide.
Sir?
Just press F5, sir.
Sir, good morning, sir.
Yeah, tell me, sir.
Slideshow, sir. Bottom 3%.
Sir, not clear, sir.
Your screen is not shared now.
Yeah,
Screen
now
share
I
is
stopped sharing the thing, sir. Now I had shared the thing, sir. Is the screen visible, sir? Is the PPT visible, sir? Gowda,
Yes,
sir?
sir.
The screen is visible, but may change for PPT presentation.
Sir, in bottom,
I
sir, in
think,
right side bottom,
Okay, sir.
it is less than 50%. You just see there.
Okay, sir. Okay, sir. What shall I do, sir?
Just you maximize that, it will get more. No.
Is it okay, sir?
No, there is
No, sir,
50%
sir.
is there, no, sir. Left side of it, there is one slide show. You just press it.
Yes, sir.
Otherwise, you press F5.
F5, sir. Press F5.
F5. Okay, sir. Is it okay, sir?
No, sir.
No, sir.
No, it is just maximizing, but it is not getting full screen, sir.
Just 1 minute, wait, sir.
Just press
I'll get-
F5, sir.
I'll get some support, sir. Just a minute, sir. Good morning, Thambi. The screen எனக்கு கொஞ்சம் press பண்ணிட்டு போ. Presentation போயாச்சு. Window தானே. இத உங்களுக்கு பெருசா தெரியணும். Sir, is it okay right now, sir?
Sir,
Gowda,
make
sir?
it as a presentation view. Presentation view, sir. F5. Press just F5. In the keyboard, just press F5.
Function
M5.
function
F5.
key 5.
Function key.
Is it okay? Okay, sir?
Sir,
Sir, is it okay?
press F5 key.
Yes, sir, I get pressed, sir, already.
There is an option in the screen.
தெரியுமா நீங்க அம்மாங்க?
And Dr. Nirmal Kumar, sir.
Sir?
Sir, 1 minute. I'm Nagarajan. Sir, you go to slideshow in the top, no? Slideshow is there.
Okay, just wait, sir. Just wait, sir.
You click the slideshow and go for full screen. Slideshow full screen.
Slideshow full screen. Slideshow full screen. Slideshow போயாச்சு. Screen என்ன பாருங்க இது. இல்ல. கடைசியா வரமாட்டேங்குது உங்களுக்கு வரமாட்டேங்குது.
Dr. Nirmal Kumar, sir, F5, have you used F5?
Sir,
Option.
yes, sir, I pressed the F5, sir, but here I am having the full screen, sir.
Sir, now click the from current slide. From current slide. Click from current slide.
Okay, sir?
No, sir, still.
Sir, just 1 minute, sir. Just 1 minute, sir. Just hold a minute, sir.
Okay, sir. Okay. Take your own time.
இதுப்பா. எங்க இருக்காங்க? Sir, is it okay right now, sir?
Yes, sir. Clear.
Yes, sir.
Clear now.
Yes,
Yes, thank you, sir.
it is correct, sir.
Nirmal Kumar, sir. Thank you.
பண்ணிட்டு அப்புறம் இது பண்ணிட்டியா? ஓகே. இல்ல இது மட்டும் தான் தெரியும். இப்போ பிபிடி மட்டும் தெரியும். சாரி சார்.
No problem, sir. You continue. It's now it's okay.
Okay, sir. Okay, sir. So sorry for a little bit hindrance. So now let us go on to our presentation. So first, let us see what is meant by e-waste. E-waste, it is the, I hope you know, after whatever the things we buy, I think we can take our mobile phones. Okay, so what we are doing after 3 or 4 years, it's useful life period. Okay, after the useful life period, what we are doing, we are replacing the mobile. Sometimes we are giving the mobile phones to the, I mean, if you are buying through Amazon, what we are doing, we are giving the mobile phone, and those people are doing, either they are going, either they are refurbishing it, or sometimes they are they make it as a e-waste. Okay, so after the useful life, all the e-waste. Okay, so starting from our I think many people, if engaged people, if any people are attending the thing, they doesn't know what is meant by VCRs, VCPs. VCRs means video cassette recorders, video cassette players. This was very famous in the till 1990s. Before 2000, these things are very, very famous one. Okay, then televisions. Earlier we had the television. I hope you know it's a very, very big in size. Now we have replaced the big television with the a little bit thinner one. Then once again, even the thinner was replaced with now LCD players. Then now it was still it is few people have replaced with the LED players. Okay, they have replaced with the LED players. Okay, so these are all the e-waste. This is the way why we are getting the e-waste. Okay. Here not only that, even our computers. Okay, earlier we had the computers. The computers were very big in size, and those were now replaced. Now we are having the most slimmy computers. Even in my room, I had replaced. So far, I had replaced 2 computers. Okay, earlier we had a very big computer. Now it has been thrown into trash. Okay, then our telephones, mobiles, then fax machines. Yes, of course. I think nowadays the fax machine, it is totally became obsolete, or we can say it is an outdated one. Okay, now because only in government agencies we are having these kind of fax machines, and instead of that we are having the emails. Now these emails, once these emails got famous, it totally replaces the entire fax machines. Okay. So all these things, okay, I had given only few things. Even we can, if you go to our house, we can take our fans, our air conditioners, or we can take our the air conditioners. I can give you a quite interesting thing. Earlier we had the window type air conditioner. Then we replaced the window air conditioner with the split ACs. Then we have replaced even the split ACs. We have replaced with the cassette style. Okay, so nowadays all these things, even our fridges, even our mixies, even our grinders. Okay, due to the evolution, due to the modern equipment technology. Okay, all these things, it has been replaced, it has been obsolete. Okay, and all these things are became a electronic waste. Okay, just to imagine, don't go for our entire country, just to imagine what it happened in our house. Okay, even I think many people are still older than me. Few people are above 50, and few people are above 60. And even at my age, at the age of my 43, 2 to 3 times we had replaced our things. Replaced our starting from what to say, that televisions, that mixies, that fridges, that ACs, that telephones. Okay, all this and in fact we can say mobile phone. I think. From 2002 or 2003, we started using the mobile phone. Right now, I think I had replaced around 7 to 10 sets. Okay, just to imagine one single house, if this much of e-waste is getting generated, imagine how much it will be in a small town, and imagine how much it will be in a country, and in a world perspective. If you say, it is a lot of things. That the information it's coming. In the forthcoming slides, we'll be having those information. So these are all the e-waste. Okay, these are all the e-waste, and majorly, okay, now as an this is an general information. As a technical person, we have to see. Okay, as a technical person, we have to see. So take, I think each e-waste, it will be of different characteristics. Okay, for example, if you take the TV, it is having a different characteristics of e-waste. If you take a fridge, it is having a different e-waste characteristics. If you take the washing machine, or if you take anything, all the things, it is having a different characteristics. The characteristics of e-waste, it is not an homogeneous one. It is purely an heterogeneous one. So as a technical person, we have to have this in our mind, and moreover, as a civil engineer, we should have this in our mind. Okay, now coming to the thing. Okay, how this e-waste is formed? Yes, just because of the technological revolution and industrial revolution. I hope these things, everybody in most of our houses, we have imagined that. If anybody, I think a few professors will be in the age of 50 plus or 60 plus. I think in their lifespan, in this, I mean, from 20 years to this 50 years, in this 33 decades, they would have experienced a lot of industrial revolution and technological revolution. Just for a small example, let me give you our mobile phones. If you see the mobile phones, just earlier it was I think in India it was introduced in the year 1995 and 96. It came to India, and in 1996 the mobile phones were this much in size. Okay, the person who is having the mobile phone, they are considered as the prestigious people. Okay, only very rich people, they will be using the mobile phones, and it will be very bigger one. The phone is very bigger in size, like a brick we had a size. Okay, then now if you see, it is very, very smaller. Okay, and a few people's in iPhones, they are very costly phones, and few rich people, so they are having a very semi phones. Okay, just because of the technological revolution, this e-waste, it's more form. Okay, and due to mass replacement, okay, because due to mass replacement of all the things, starting from television to computers, this e-waste, it is getting formed. Okay, then these are all the mobile phones and Kindles, e-diaries. Okay, and this e-diaries in the 90s and 2000, this e-diaries, it is very, 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 very famous. Okay, there is a craze for this e-diaries. Okay, there is a case for this. A craze for this e-diaries. What they used to do, the youngsters, both the boys and girls, they will be having the e-diaries to note down the day-to-day schedule, to have a mobile number. I mean, to have the phone numbers. Earlier days we had only the phone numbers. Okay, all these things. And this Kindles, I think this just before 5-6 years back, it was more into the market. Kindle, it is an equipment used to study. Okay, we can upload the things in a PDF. Okay, for example, if you're going by a train or by a bus or by a car or by a flights, okay, in order to pass time, we'll be having the Kindle. And in Kindle, for your information, it is a small in size. It can upload up to 10 GBs or 20 GBs of PDF files or Word document files. Okay, we can upload the thing. It's almost like a mini, we can say mini laptop, or we can there no processor will be there. Okay, like an iPods, or we can say it's like an computer, it's just a reading tool. Okay, this Kindles, this Kindles also becoming the e-waste, because after one certain point of time, they are stopping using the Kindles and they are going for the new Kindles, and computers, laptops, mobiles, everything, just due to its capacity. All these things, it is becoming the e-waste. And this, now let us come to our technical aspect. Okay, so in the e-waste, these are all the main composition. These are all the main composition. Iron and steel, it constitute around 50%. Plastics, it constitute around 21%. Non-ferrous metal, it constitute around 13%. Others, it constitute around 16%. Okay, so these are all the technical things we have to know. These are all the technical constituents we have to know. Okay, all these things so far we have studied prerequisites. Okay, all this general information, just to have few information how it's getting generated and what's meant by anyways. So these are all the constituents, and we have to see how this can be accommodated in our concrete. So here they had given the thing. Apart from this, metal content is around 28 to 30%. Copper it is 10 to 20%. Lead it is 1 to 5%. Nickel it is 1 to 3%. Okay, and even sometimes silver, platinum, and gold present in the scrap of 0.3 to 0.4%. So the other materials are plastics 19%, bromine 4%, glass and ceramics 49%. Okay. Besides these inorganic elements, even some organic compounds were also, observed. Isocyanates, phosgene, then acrylic, then phenolic resins. Okay, all these, not only the inorganic things, even the organic things are also found in the our things, our e-waste. Okay, and let me ask you an simple thing. Sir, whether this composition will be same for every e-waste, sir, or will it be different, sir? Sir, madams. Whether the chemical composition, will it be same for all the e-waste or it will be different? Anybody, sir?
I think it will be same.
Varies, I think, sir.
Sir?
Varies, I think.
Magesh, sir, louder, sir?
Varies, I think, sir.
It is same.
It's different for all.
Same. How it is same, sir? Okay, let me ask you. Let us have a discussion, sir. Whether we are having mobile phone and we are having television, sir. In television, we are going for LED screens. We are going for LCD, cathode rays, CRT, etc., sir. But in mobile phones, we are not having, sir. Whether the chemical composition will be same, sir?
No.
No, it is not same for all.
Yes, sir, it is not same for all, sir. And at this juncture, let me tell you one more thing. If you are going for research work, if you are doing research work, okay, so we have to test the, first we have to have a clear-cut idea which e-waste we are going to use it for our experimental work. Okay, whether we are using television sets or whether we are using refrigeration. Okay, because in refrigeration, as we are having many organic compounds. Okay, sometimes we'll be having that the coolant. Okay, all these things, it will be an the chemical composition, it will be different. So before going into our research work, before going into our experimental research work, we should be clear-cut, we should be on a clear-cut basis which thing we are going to use. Okay, which thing we are going to use. Okay, then only we can go for our we can then only we can choose our materials. Okay, for example, if you are doing some experimental work, either we have to choose all the television sets. Okay, we have to use all the television sets, or we have to use all the refrigerator sets, or we have to use all the mobile phones. Okay, if you categorize this and if you do the experiment, if you proceed with the experiment, it will be easier one, or else it will be a difficult one. Sir, is the screen visible, sir?
Yes, sir, visible.
Yeah, thank you, sir. So, so these contents, okay, these contents, they have given generally, it may vary from one component to other component. Okay. Now, scenario of e-waste disposal. So, mostly what we are doing, we are going for landfills. Okay, and the landfills even it's a little bit we are having leachability problem. Okay, and these e-waste, just like that, we cannot put it on the land. We have to go for a proper disposal and reusal. And while disposing the thing, we have to have a proper skilled person. The supervision, it should be a pakka one. Okay, whether we are going for a landfill or we are going for an incineration, anything. Okay, this so our supervision should be a better one. And this underground water quality, 100% there may be a chance of getting affected. Okay, even the humans, even the animal health, all these things, it is under the mercy of this e-waste. So we have to be very, very careful. And another one more important data, it's around 53.6 million tons. Worldwide it is 53.6 million tons. And in India it is through 3.2 million tons. Okay, in India it is through 3.2 million tons. Okay, of electronic waste are generated. And in developing countries, we are not having proper regulation to dispose this e-waste. Okay, and due to that we are having the harmful impacts also. We are having the harmful impact, and sometimes even it is polluting the environment, and as a result, as a consequence, even our entire ecological cycle is being affected. And this I want to at this juncture, let me give you an example of have you all seen Singham movie? I think in Tamil Nadu it was very famous. I don't know how about in Telugu also it was famous. Have you seen Singham movie? I think
Yes, sir. Singham 2.
Singham, yeah, Singham 2. Yeah. Singham 2 or Singham 3? That Australian
Sorry.
Singham 3, I think so. Am I right? Singham 3.
Yes,
think
sir.
so.
Singham 3, yes, sir. Yes.
Yeah. See, I think while seeing that movie, we will be thinking that it is only an imagination part, and just to have the entertainment they are giving, they are exporting. I mean, they are importing the e-waste and medi-waste from Australia, and they are dumping it in Hyderabad. Okay, nearby Visakhapatnam area. Okay, but it is not a story. The only thing is it has not happened in India. But if you take we will be calling it as a third world. Okay, we'll be calling those Ethiopia, Somalia. Okay, all these African countries, we will be calling those countries as a third world. Okay, underdeveloped peoples, and there is no awareness at all. Okay. They doesn't know, and for your information, in few of the African countries, still they are not having they are not exposed to internet. They are not exposed to electricity. They are not even exposed to our mobile phones, etc. Okay, if even in TV also it is not available in few of the African countries. Okay, there exclusively in Ethiopia, exclusively in Somalia, exclusively in Ethiopia. Okay, what happened is the e-waste from Italy, the e-waste, the medi-waste. Okay, what has shown in the Singham 3 movie, it has happened in Italy. Okay, that is the reason. If you see in Ethiopia, you are having a lot of health problems, and there have many containers from Italy. It has been dumped in Ethiopia. Okay, and that is the reason many people are having skin problem. Not only skin problem, the entire agriculture thing, it has been totally. It has been spoiled in Ethiopia. Okay, so that it has happened in our Somalia. Okay, Somalia and Ethiopia it has happened. And if you see, the thing is, we have to be very, very careful. Okay, only luckily our Indian government, it is not permitting the import of this e-waste. Okay, it is in India, in Indian rules and regulation, it is banned. Okay, so these are all the consequences. And here let me give you a small statistics. So this was in statistics in 2019. Okay, the 2020 statistics, it is yet to come. Now only they are getting the information. And for your information, this is approximated up to 90%. This data are approximated to 90%. And if you see Norway, okay, it is producing 26 tons, and million tons, it is 0.1 million tons, and UK it is 23.9%, and it is 1.6 million tons. Switzerland it is 0.2 million tons. Denmark it is 0.1 million tons. Australia it is 0.6 million tons. Okay, this is with respect to the people. Okay, this they had calculated with respect to the quantity of the population. Based on the population, they had arrived at this thing. In Netherlands, it is 0.4 million tons. In Ireland, it is 0.008 million tons. US, it is 6.9 million tons. And in France, it is 1.4 million tons. So these countries are producing more amount of things. And India, comparatively, it is a little bit lower. Okay. And here in India, we are having the information. So this International Association of Electronic Recycler, IAER. Okay. they had given a report. So 3 billion electronic and electrical appliances became e-waste in 2010. Okay, 3 billion electronic and electrical appliances became e-waste in 2010. Globally, it is about 40 to 60 million tons, yes, of course, we had seen it, and which accounts around 5% of the municipal solid waste. And in India, actually in India, Comptroller and Auditor General, he is an Indian Accounts and Audit Service Officer, IAS officer. So he is the authority to give the real picture of what is the e-waste generation. So it is 7.2 million ton of industrial hazardous waste, 4 lakh tons of electronic waste, and 1.5 million tons of plastic waste, 1.7 million tons of medical waste, and 48 million tons of municipal waste are generated in our country. And it is 7. And for our discussion, it is 7.2 million tons of waste. Okay. And Central Pollution Board, our CPCB, okay, that it is called as the Central Pollution Control Board. So it are estimated that we are having around more than 8 lakh tons. They are given an estimate. We are generating an e-waste of about 8 lakh tons. Okay, so there are 10 states in our country. There are 10 states in our country which contributes to the 70% of the total e-waste, and 65 cities generate more than 60% of the total e-waste in India. Okay, I think these are all the top cities, cosmopolitan cities like Mumbai, Delhi, Bengaluru, I think Chennai, even Chennai, Ahmedabad, Hyderabad. Okay, so these constitutes around 60%. All these 65 cities contributes around 60% of the e-waste. Okay, and Bihar is the least generous of the e-waste. Of course, in Bihar, I think it is a little bit an underdeveloped state. And for your information, just to know an information I'm giving, even in Bihar, even in few villages, they doesn't know what is only electricity, or they doesn't know the awareness of more internet. Okay, so still it is a developing state in our country, so that the generation of e-waste is very, very less. And the main source of electronic waste in India are the government, public and private, and industrial sector. And household, it contributes around 15%. So here comes television. E-waste in India: television 68%, desktops, that is the computers, 27%, and imports 2%, mobile phone 1%, others 2%. So the television and the desktop, it contributes to the major percentage. So here, as a technical person, we should see if you want to do research work in the e-waste, if you want to do research work in the concrete, okay, then I think it is better to go for taking the televisions and computers. Okay, taking televisions and computers, it will be very easy for our research work. And my UG students, they did it with the help of the televisions. Okay, because they got television for a very cheap rate in television shop. Just they broken and powder, and they can use it for the concrete. Okay. I think e-waste economy in an organized sector. This is just an general information. More than 90% of the e-waste generated in the country end up in the unorganized market for recycling and disposal. This is an very, very greatest danger to our country, and mostly in few metropolitan cities like Mumbai and in Gujarat, Ahmedabad and in Chennai, what they did is they are simply putting the e-waste in the dumping areas. Okay, dumping yards. Okay, so-called municipal dumping yards. They are just putting it, and even those laborers who are handling this thing, they are not properly using the even gloves. They are not using. They are not using gloves, or they are not using the proper face masks. Okay, all these things are very, very dangerous one. And for our information, while doing our experiment, okay, if you are using e-waste in concrete, just to please wear all the gloves, and just be very careful. Even you have to instruct the students to be very, very careful. And these methods of disposal of e-waste, usually landfill. So landfill, mostly we are going for the burial. It is very, very dangerous one. And mostly if you go for landfill will be having the leaching properties. Mostly all kind of, not only sulfate and chloride, will be having leaching property with all kind of leachings. Okay, not only sulfate chloride, even if we having nitrate, etc., etc. And while burning also, we are having lot of issues. Okay, even while doing the incineration, toxic substance it will be evolved. And for your information, sometimes you are having the organic matter, isocyanates. Okay, if your isocyanates are burned, even sometimes it may lead to lead to the problem for respiration, and sometimes even death may occur. And sometimes they are converting the e-waste into the ash. They are converting the e-waste into the ash. Okay, and that ash also sometimes they are using in the fine aggregates. I mean, sorry, yeah, they are using it by replacing the fine aggregates. So then comes the recycling. So recycling, yes, I think it's only a small part. We cannot go for a larger recycling. Okay, just we can go for a smaller part of the recycling. If you go much more for recycling means, then once again, up to some extent, we can use it for recycling. After a particular point, we cannot use the same objective. So this is also not a proper disposal. Then reuse, yes, reuse also same thing. I think mostly nowadays, even we are stopped using the second-hand things. Even the second-hand products, even in India, as developed countries, still we are going for the new bikes, new cars. Only very few percentage nowadays they are going for the second-hand use. Even these kind of e-waste also, it's a big. There is no big market for the reuse, and these are all the effects of the e-waste disposal. So long-term harmful effects, and we are having more than 60 different types of metals, and there are also mercury, cadmium, lead. Okay, all these things are present, and so Indian government is taking a lot of mechanisms. They are formulating a lot of rules and regulations. Okay, to curb the e-waste. Okay, I think even at one point of time, even we may have a chance of exporting the e-waste to some third underdeveloped countries. There may be some possibilities. Okay, and even in India also, we are having an alarming situation. Okay, it's the situation. It is a little bit not a successive one, and these are all the various impacts on the environment. Okay, so surface water, groundwater, reservoir, all these things, it is getting contaminated. Okay, so it's a big problem both to the environment as well as to the soil. And reusing, yes, we are having a little scope, but not big scope is available. Okay, and I think we can go to, yeah, these are all the PCBs. Here, if you see, once again, I repeat the thing. If you go for experimental work, just you choose any one. Okay, either if you want to go for a computer, if you want to go for using the computer, just use the computer. Or if you go for capacitors or TVs, just use any one. You should not combine all the things. I think we can go to the, yeah, we can go to the reviews. So before getting into the thing, okay, now let us see the review. And here, sir, anybody wants break, sir? Sir, organizer, sir, because just it is around 1.25 hours.
You can continue, just so it's not planned so far.
Okay, sir.
So we can continue, sir. We can continue up to 11 o'clock.
Okay, sir.
You want any interval, sir? You need just, if you want a break, you can continue up to 10 minutes.
Yeah, just 5 minutes, sir. Just 5 minutes of break, sir.
Okay, sir. Okay. Thank you. You take a break for 5 minutes and then again.
Yeah, now the time is 10:11, sir. Just by 10:15 or 10:16, we will continue, sir.
You can, okay. Thank you, Professor. Thank you. Dear participants, please wait for another 5 minutes and again you join. You can discontinue and join. Thank you.
Sir, can I start, sir?
Welcome, Professor. You can start now.
Yeah, thank you, sir. So I think let me go to the. Sir, is the presentation visible, sir?
Yes, sir, visible.
Okay, sir. Okay, sir. Now I think we are going to see the experimental results, sir. So this was this particular experiment. It was carried out by Panneerselvam et al. In 2016. So what he did is he prepared the different types of M20 grade of concrete specimen with the partial replacement of e-waste on percentage of 10%, 20%, and 30% with the coarse aggregate. Okay, and here he had the water cement ratio of 0.45, and he had given the results. Okay, here he had given the results up to 20% replacement of the e-waste for coarse aggregate in concrete. It shows the improvement in the compressive and tensile strength. Okay. Here I think only just because he had replaced with the 20%, okay, that was not a big issue. But if we go for higher percentage, okay, if we go for the higher percentage, we'll be having some issues. And he had comparing the results of the conventional concrete at 28 days, it was observed that the strength of the concrete is reduced by 30.7% when coarse aggregate is replaced beyond 20%. So he had optimized up to 20%. Still, he had carried out the experiment, but up to 20%, he had recommended the usage of the e-waste replacement in the concrete. And here he had given the results. Okay, so this is conventional. This this is by this particular one. It is made with the help of M25 grade of concrete, and it was done in 2015 by Kanniyappan et al. On that day, and they had used 10%, 20%, and 30% e-waste concrete for 7, 14, and 28 days. Okay, so they had given the result, and the blue line, it indicates it's the conventional concrete. In conventional concrete, it was not replaced. It is zero replacement of the e-waste. Okay, that is for M25 grade of concrete. At the seventh day test, 10% e-waste, it is a little bit more than the conventional concrete, and 20% concrete, it is having a more compressive strength than that of the conventional one. And beyond 30%, I mean in 30%, the concrete strength, it is getting decreased, and I hope even the it is a little bit less than that of the conventional concrete. It is a little bit less than that of the conventional concrete. So I think his observation, his inference for the seventh day of compressive strength, beyond 20%, the compressive strength, it is getting decreased. Okay, almost the same thing. It is observed in the 14-day strength and 28-day strength. I think we have to little bit see this 28 days compressive strength. Okay, I think this particular result, it is good. So up to 20%, he is having more than 30 Newton per mm square for M25 grade of concrete. He is having around 31 or 32 Newton per mm square. So up to 20%, we can, as per his observation, he has used up to 20%, beyond which there is a reduction in the strength. Then same Kanniyappan et al. He had studied for the tensile strength. Of course, always the tensile strength, it will be always less than that of the compressive strength. Okay, and we are having around here, if you see the tensile strength, I think a bit good observation. Let us discuss only about the 28 days. So the conventional concrete, it is around 6 Newton per mm square. And this particular 10%, it is more than something around 6.2 or 6.3 Newton per mm square. But if you see the 20% replacement, it is around 6.5 Newton per mm square, or little more than the 6.5 Newton per mm square. And here, I think in comparison with respect to the compressive strength, this tensile strength result, it is better. The tensile strength result, it is better. Maybe due to the chemical content, or that inorganic content, like either a small amount of copper or a small amount of steel. Okay, maybe due to that thing, the tensile property may have a little bit improved. Okay, so compared to the compressive strength, I think the tensile strength it is better as per his inference. Then one more, I think he had given the inference for the flexural strength also. I think here the flexural strength also, we are having a good one. Okay, let us discuss only about this 28 days compressive strength. So in this 28 days compressive strength, the conventional, it is around 5 Newton per mm square. Whereas if you see the 20% replacement and 10% replacement, it is a little bit more than that of the conventional one. And it is a little bit around more than 5.3 Newton per mm square. So here, I think he did it for the slabs. So here he had a good result comparatively, because always we have to have the compare with the conventional one. So with respect to the conventional one, it is the behavior, it is a good one. So Kaniyappan, from his all the 3 experiments, okay, I experiment on the compressive strength, on the tensile strength, on the flexural strength. Okay, these are all the observations he had given. So compared to the compressive strength, the tensile strength and flexural strength, it is having a good one, and the 2 tensile strength, we are having a good, significant improvement than compared to that of the conventional one. I think these kind of things, we can use it for RCC areas, or we can use it for some specific structures where more amount of tensile strength is required. So these are all the inferences we observed from the Kaniyappan. Then Amiya Akram et al. Okay, in 2015, they did the experiment, and they did the experiment. They determined the compressive strength and split tensile strength, and the mixed percentage, he had varied from 5, 10, and 15%. He had varied from 5, 10, and 15%, and he had compared with the conventional one. Okay, compared with the conventional one, and he had used fly ash 10% of the fly ash. Fly ash, it is an pozzolanic material, and he had did it for M20 grade of concrete. So, so first let us see the compressive 28 days compressive strength. Okay, for 0% replacement. Okay, the 0% replacement. It is even the e-waste. E-waste is little bit more, and for 5% replacement, it is more by 5 Newton per mm square. For 10% replacement, of course, it is more by 7.5 Newton per mm square. That is for 10% replacement, it is around 80 conventional concrete, it is 80 Newton per mm square. But whereas the e-waste replacement for 10% it is around 22, and for 15% also it shows a better result, because when we compare with the earlier 2 studies, both the things for they had up to 20 they had the improvement, and beyond 20 they had a significant fall. I think even if this experiment, if you had gone for another 20% also, even the graph would have been better. So this is the observation for the compressive strength, and let us see the tensile strength. I think here we are having a different scenario. When we compare with the Kaniyappan et al. Here, the tensile strength, it is initial days, it's okay. Up to 10% it is okay, but beyond 10%, even in the 15%, the tensile strength, it is very lesser. This may be due to the materials taken by the Akram et al. And the Kaniyappan et al. It may be a different one. That is the main reason we are having this kind of thing. And you may have this kind of inferences. Based on this kind of inferences, we have to choose the proper materials for the replacement. Then he had observed 10% fly ash was added results compared to the control specimen were obtained even for 15% proportion of the e-waste. Replacement of this waste in the concrete reduces the requirement of conventional coarse aggregate, and as a result, even the natural resource it can be, it can be conserved. The specific, the main thing we have to know is the specific gravity. The specific gravity of the e-plastic is much less. This is a very big issue. So to counteract this, we have to either we have to go for some research work where we have to determine the what to say that a proper dosage of admixture or a proper chemical to improve the specific gravity and to have a counteraction. So as far as this 20% is considered, 15 or 20% is considered, it is good. And moreover, they had added with the fly ash. So fly ash also, it's a good pozzolanic material. It is also, it may be one of the reasons to have a little bit good in strength. Then this experiment, it is done by Ashish B. Tone et al. In 2020. This is recently he had carried out the research. What we have did is he had just replaced with around 3%. He had not gone for more than 3%. Okay, and he had a micro analysis. Okay, he had a micro analysis. Probably he might be doing some research work. That's the reason he had went for this micro analysis. And in this, he had given what is the weight of replacement, whether the weight is increased or decreased due to the addition of this e-waste. I think this gives a lot of information. Now let us discuss about the information right now. I think this will be an interesting information also. So for 10%, he prepared the concrete cube. So it was around 8 kg, and I think not concrete. He had added thing. And the strength, the compressive strength, let us take the compressive strength, and they had given the average for both the 7 days, 3 cubes for 7 days and 3 cubes for 28 days. Let us take only this 28 days. It is for M20 grade of concrete. We had did this experiment for M20 grade of concrete. So it was 28.65. It is really good one. It is really a good one. Then he went for 0.5 replacement of the e-waste with the coarse aggregate. So here, if you take, he got it for 29.22 Newton per mm square, which is greater than that of the, which is greater than that of the conventional aggregate. Then he went for 1% replacement. Yes, in 1% replacement, it is giving 30.4 Newton per mm square. But for 2%, here it was 25.73. When we compare with the 1%, it is 30.40. But for 2%, it is 25.73. So it has been now here itself it has been started decreasing. And if when he went for the 3%, that also because once it started decline means it will be starting declining. But you may have a doubt why for till 3% itself it is getting decreased. That is the reason I have told you. The main thing, what is the e-waste they are using it for the experiment. For example, suppose just I'm giving you an hypothetical conditions. See, if you use televisions, okay, if you use television, okay, in television you are having a lot of empty spaces. Okay, the density and the strength it will be very, very lesser. But when we go on the same hand, when you go for an mixie or when you go for an washing machine, it is a little bit stronger. The body is a little bit stronger. Okay. That the entire property, it will be varying. Okay. So based on that case only, here the strength may decreasing or increasing. Okay. That is the main reason. And he had used, this is for the concrete cube. He did the experiment on, he replaced the e-waste to the concrete brick also, and he carried out the experiment. And in this experiment for 0%, the mean strength here got 50.16 Newton per mm square. And when he replaced 5%, he got the same 50.15 Newton per mm square. And when he replaced 10% and 15% also, he got the same 50.38 and 50.14 Newton per mm square respectively. And here what we can infer, it is for concrete cube, it was decreasing, but for concrete bricks, it is almost the same. Even for the conventional aggregate also, we got the 50.16 Newton per mm square, and for 15% replacement also, we got around 50.14 Newton per mm square. This is for the, he did the same experiment for the power blocks, and power blocks for 0%, for 28 days of curing, it is 2.5 Newton per mm square, and for 5% replacement, it is 2.47 Newton per mm square, and for 10% at the end of 28 days, it is 1.65 Newton per mm square, and 15% it is 5.97 Newton per mm square. Here, and the 15% at the end of 15% is having 5.97 Newton per mm square. Since the power block, the thickness, it is maybe 60 mm thickness, or it may be a little bit lower than 60 mm thickness. Okay, so that the strength, it is comparatively in comparison with the 0% and 15%, you are having the difference. Okay, so this is pertaining to the power blocks. Okay, and this is for the tensile strength. We have carried the experiment for the tensile strength. For tensile strength, 0%, I mean the conventional, it is 3.78. For 0.5%, 4.26, 1% 3.65, 2% 3.61, and 3% it is 4.16 Newton per mm square. So here also, if you see, for a concrete cylinder, the tensile strength, it is getting increased when the percentage is increased. Okay, and here we can optimize by using the 0.5% of e-waste, we can have the best result. We can have 4.26 Newton per mm square, which is the best result. So here, if you see, all the, I mean, the results are varying from one component to the other component. Now we had used it for the concrete beam. So just here, conventional, it is 0.697 Newton per mm square, and when it is gone for 0.5%, 1%, in 1%, he is getting the maximum strength of 0.82 Newton per mm square. So here, when we observe, here when we informate, here the different things are for a different component. I think from 5 things. Okay, first one, we had the concrete cube. Second one, we had the concrete bricks. Third one, we had the concrete power blocks. Fourth one, we had the concrete cylinder. And fifth one, we had the concrete beam. Okay, so here, based on the individual component, whether it is a beam or a power block or a brick or a cube or a cylinder, based on that, the strength, it is getting varied. And here he had given the minute details. I think probably he may be doing some research work, in-depth research work in this thing. So here, based, for example, if you go for the slabs, if you go for the beams and all, we can use the we can use 3%, or we can say we can go for 1%. Whereas if you go for some where the place it needs more amount of tensile strength, where there may be a chance of little bit chance of bending, where the neutral axis it is different. Okay, then we can go for the percentage of 3%. I think 0.5%, it is better. 0.4% we are getting a 4.26 Newton per mm square. When we go for the power blocks, I think the power blocks minimum will be having if 2.5 Newton per mm square or 3 Newton per mm square. If it is that, then it is a good result. Even this 2.5 or 3, it can even resist 5 tons of lorry or 8 tons of buses, up to 8 to 10 tons it will be resisting. So if we are constructing the thing, then we can go for the 15% replacement. Okay, 15%.
Nirmal Kumar sir, your mic is muted.
Sir, Nirmal Kumar sir, are you speaking or just?
Yes, sir. Am I audible right now, sir?
Okay, sir. Thank you.
Just before 2 minutes, I don't know, a blank came, sir, and information came that somebody had muted the mic, sir. Unknowingly. Okay, sir.
Oh, okay, sir. Thank you, sir.
So, if it is if we are going for a power block, we can go for the 15% replacement because more amount of saving, more amount of e-waste, it can be used. And in the place where we want more amount of strength for the power blocks, okay, even in some industrial areas, they'll be having 15 tons or 20 tons of vehicles to be moved upon. Okay, so in those areas, we can go for the 15% replacement. And the concrete bricks, yes, of course, it's really a good experiment by Ashish. So here it is almost same. Here the concrete bricks, it is almost same for 0% or for the 15%. Only a meager variation is there. Okay, so even sometimes if it is not necessary, we can have the 0%. Or if you want to replace or if you want to reuse the thing, we can go for the 15%. And the concrete, finally, the concrete cube, it is, I think, if you go for 1%, it is the maximum compressive strength. We are obtaining it for 1%. That is 30.40 Newton per mm square. So based on this, we can come to a conclusion based on this experimenter. Okay, based on this experimenter, we can come to a conclusion that for different bricks or concrete cubes or for power blocks, okay, so based on the requirement, we can go for the composition. And so now these are all the inferences for this study. So, okay, so before getting into the conclusion, so let me once again recapitulate the experimental work done by the 3-4 peoples. Okay, still few peoples have done the experiments, but they had the results, results are not satisfactory for me, so I had not discussed about those results. And here, based on the results, if you want to go further, and you may have a questions, I think you'll be probably shooting up the questions. See, you may, one question, it is why Nirmal Kumar in the in one of the things for 15 or 20% you are having a good strength, but for here 1 or 0.1% or 2%, 3% you are having a different strength. Okay, so once again my answer is they may probably use the material, different material. For example, X may use the television, the Y may would have used the mobile phones, or the Z may have used any circuit boards, which is very dense dense in nature. Okay, so based on the materials used, there may be some chance of variation. That is one instance. And the second thing, this is an valuated information for if you want to do the research work, if you want to carry out the research work in your future, if you want to carry out the research work in future, please go from the basic fundamentals, starting from the workability, from the compacting factor. Okay, because nowadays in journals, if you, I think, if you want to complete a PhD, you have to publish a paper, 1 or 2 couple of papers in the reputed journals. So in this case, what we have to do is, we have to go from the micro level. All the micro level studies we have to go. Even the durability studies we have to see. Okay, even we have to predict, or we have to forecast what will be the end result if you are using it for a concrete beam, or if you are using it for a concrete cube, or if you're using it for if you take the power blocks, means you are having a lot of issues pertaining to the leachability. Okay, we're having a lot of issues pertaining to the leachability. See, main leachable will be having sulfate and chloride. Apart from this, okay, because few characteristics we couldn't able to predict because it is a new thing. Okay, so apart from this, even you can have a leachability due to copper or due to steel in form of corrosion or due to some organic substances or inorganic substances. So a lot of things we have to take in mind and while going for the research work. So at the outset, let me conclude. The quantum of phase generated over the past several years has posed an increasing threat. Yeah, it's a very, very increasing threat, and we have to find an alternative to use these things. Okay, the only alternative is we are using the few wastewater in concrete. Okay, replacing the potable water in concrete. We have to replace the e-waste or some kind of e-waste with either with the fine aggregate or coarse aggregate to safeguard the environment. And as long as the electronic products continue to contain an assortment of toxic chemicals and are designed without recycling aspect, it's a big threat to the ecology. Okay, not only even if you see the aquatic, the sea area. Just before 3 years back, there was a big, rainfall, huge amount of rain in Mumbai. What happened is the water, it has been choked, and all of a sudden, since more amount of water has been stagnated, the water plunged into the sea. The water forcibly entered into the sea at the point of estuary. After 15 days, it is fully covered with the plastics, electronic good items. Okay, everything it was covered with the all the electronic items, all the waste items, all the polythene, plastic, papers. Okay, what happened is many aquatic species, starting from the fishes, starting from the many squids, okay, many things it has been died. It has a big threat to the environment. So we have to be very, very careful in recycling this e-waste. So let me summarize the things what we have discussed here. So first we have discussed about the basic things, that is the prerequisites. Then we have discussed about what is meant by e-waste. Then we have seen how e-waste is formed. Then scenario of e-waste disposal, then methods of disposal of e-waste, effects of e-waste disposal, scope of reuse of e-waste, then recycling of electronic waste, and few observations and reviews. And these are all the few references. Thank you.
Thank you, Dr. Nirmal Kumar sir. Now the session is open to participants. If you are having any queries regarding this, and also many of you may have work on a research side. So he is having vast experience in research and is guiding more than 10 PhD scholars. So if you are having any clarification questions, kindly use this opportunity. Thank you.
Sir, even if you want, you can post the questions in chat box, sir. I'm ready to answer.
Sir Gangadhar, Bangalore Institute of Technology. My question is, when we add
louder,
the...
Sir, louder, little bit louder, sir.
Yes, when we add this e-waste to the concrete, it will make the concrete little porous, because how it will be the compatibility of this e-waste with the cement, and how it will, because you are not mentioned anywhere in your slides about the compatibility of this e-waste with the cement.
Yes, sir.
How it will be compatible?
Sir,
because it's a plastic or it is some other metal. How it will going to attach to these concrete?
Yes. Well, you are asking about binding properties, sir.
Yes,
sir. Actually, when we are start doing the experiment, we had a little bit notion as what Gowda sir told. Okay, actually, once if you mix the water and when we take the conventional coarse aggregate, it is having a good binding with the water and the fine aggregate. But when we use the e-waste, okay, it is not having equal binding as that of the conventional coarse aggregate but it is getting binded, sir. 100% definitely I can say it is not as compatible or binder as that compared to that of the course aggregate, but yet for doing our experiment, for doing our research work, it is getting binded, sir. It is mixing with the other components, sir. It is getting accommodated with the other components, sir.
Okay, okay. Thank you, sir. Thank you.
Yeah, I think there is one question. Shape of e-waste. I think Mahesh or VVS had asked a question. What is the shape of e-waste? Well, sir, here two things I want to make it clear, sir. One thing, when we go for the replacing or adding, when we are going for the replacing the coarse aggregate with the e-waste material, okay, then we have to break in sizes of 20 mm size approximately, or 12 mm size we have to break, sir. Okay, generally we are going for M25 grade of concrete, so M20 20 mm size it is okay, sir. It is okay, sir. And the shape, if you see, it is not regular shape as that of our coarse aggregate. Even coarse aggregate, it is not in regular shape. So here also the shape, it is not in regular. We are having sometimes rectangular one, we are having sometimes a porous. Okay, the e-waste, it is having a porous material. Sometimes it is like an irregular shape, like a rectangle also we are getting. Sometimes like a triangle we are getting. Okay, all the shapes we are getting. And one thing is, since it is of irregular shape, it is easy for, since it is a irregular shape, it is having a good bonding with the other material. So this is the, am I answer is right for Mahesh, sir?
Sir, if you are considering the plastics, we can getting the flakiness or the elongation content is more.
Yeah.
Right, sir?
Yes,
So that's the major problem in the basic rule for concrete, right?
Exactly, sir. Exactly. That is also a problem, sir. Based on the experimental results, we are getting the minimal results, sir. For up to M25 grade of concrete, we have did, sir. Even I have did the experiment with my UG students, sir. Up to M25 grade of concrete, M20 and M25 grade of concrete, we are getting the results, sir. Even though it is a flakiness, even though it is something, we are getting, sir. This is one answer, sir. Another thing, I had told you two things now. Another thing, one of the student, what he did is he powdered the e-waste, sir. There is one machine in our institute, sir, in our Department of Chemical Engineering. We are having one equipment, sir. That particular student, he powdered the e-waste, sir. Okay, and he replaced with the fine aggregate, sir. But since the specific gravity is not it's varying, we couldn't able to get a good result, sir. Okay, so am I answer satisfactory, sir?
Sir, once again, sir, if they are doing the powder form, then it can make chance of replacing the cement. So if they are doing the powder form, it is the least size.
No, sir.
Again, least than the sand.
Sir,
again, there is a problem of.
Sir, powder, it is, even if the e-waste we are powdering it, it is not having the binding capacity as that of cement, sir. Sometimes even it is not having the property as that of even fly ash we are using, but this e-waste we cannot use it for replacing the cement, sir. Its chemical composition are different, sir. There, if you take for cement, lime, silica, alumina, iron oxide, magnesia, alkali, sulfate, sir. These are all the compositions, sir. When we come for this e-waste, sir, its chemical composition is totally different, sir. So we cannot replace the e-waste with that of the cement, sir.
Yes, sir. But what I am saying is, if I am replacing coarse aggregate, it's difficult about the shape. If you are replacing with fine aggregate, there is some gradation problem, I think. So gradation problem is that is affecting.
Grade problem, okay, we can overcome the grade problem, sir. But only thing is we couldn't able to get the strength, sir. That's the main reason.
Okay, sir. Okay. I will try to make a project on this.
Yeah, we can try, sir, and we can one day we can share our results, sir.
Surely. Thank you.
And I think one more question is there. What legal action can be taken in case of not following government rules for e-waste management. Sir, we are having a lot of regulations and state pollution control board had imposed a lot of conditions, sir. Okay, if you just give a complaint to that pollution control board, they will take immediate action, sir. If anything is affecting to environment, okay, that too in Tamil Nadu, the pollution control board, they are on the tip of the toe, sir. Even if you give a small complaint about either a e-waste or an air pollution or any water pollution, they are taking action, sir. So you have to complain it to pollution control board, sir. Am I answer satisfactory? Harishiv Kumar, sir? I think Hemalata Alagar, they had asked, yeah, PPT, I'll share it. And one more question. How one produce e-waste aggregate by pulverizing or we get it from market? Sir, I think in market we couldn't able to get it, sir. Only thing is we can buy the televisions, we can buy use the computers from either from an institute or from the workshops, okay, where the repairing shops, mechanic shops, where they had given the televisions for repairing or the waste televisions, okay, that we can purchase. We can break with either we can have we can break manually, we can break, or we are as we are having equipment in our department of chemical engineering lab, we are breaking the thing into pieces, sir. Sindhu Kumar, sir, is it okay?
Okay, sir. Thank you, sir.
Yeah, welcome, sir. Have you made any complaint in this with your government, sir? If so, no, sir, I had not. I think who had asked the question? Harishiv Kumar, sir. Okay. Sir, no far I have not made any complaint, sir. Because I had not seen any e-waste in and around our area, sir. So I had not made any complaint, sir. Is it okay, Harishiv Kumar, sir? Yeah, welcome. Sir, Harishiv Kumar, sir, which state you belong to, sir? Either you are from Tamil Nadu or from which state, sir?
Tamil Nadu in Trichy, sir.
Oh, Trichy. Okay, sir. Okay. I think then pollution.
Sir, while I told I traveled across the globe for my last 16 years in experience in construction industry.
Okay.
But when I used to go to different countries and different in India itself, I have our relatives are working in port and different customs. So I used to get some information. They are dumping somewhere. They are burning some e-waste, which makes affect some schools, colleges. Some children are dying. Lot of you are the great person, sir. You are making lot of research. But have you taken to government some issues, lessons learned? Have you made some sustainable things to develop our government rules and regulations? So that the concerned legal advisor, I want to know, because even though we are studying a lot, we are having a PhD scholar, but practically speaking, if you do something like that, and if you give some example, it will be very much practically helpful for us to manage, and there will be a fear to do such a big authority companies. That's what I would like to ask such questions, sir.
Okay, sir. Anyhow, sir, actually, for your information, sir, so far I have not encountered this kind of e-waste generation or e-waste burning, sir. Because just I am residing in...
Sir, in our India, even in Ganga, in Kashi, they have e-waste. E-waste is okay. That is, there are different waste are mixing in our river and you know everything basically. I don't want to communicate to you. But what action personally have you gone through? Any president, our commissioner, our state legislative, different members? Have you any influence to handle the people, handle the situations? In case of some industries not following the waste management effectively, they are trying to dump somewhere in some villages, and that makes affect a lot practically. So I want that kind of practical information, sir. That's what I would like to more eagerly learn to know. Not only e-waste, medical waste, e-waste, solid waste, concrete waste. They will try to, that will allergy to somebody, sir. That is totally allergy to somebody. It will even, I would like to know how to take up with government as an individual citizen. That is what I would like to know. As a citizen, what action I have certain rules and responsibility. If I travel to different countries, they are very, very conscious and strict to Even one message, if they give, the monitoring of e-waste management is very quite effective. They have some satellite controls, they have some CCTV controls, they have even from mobile, the owner can see every aspect, tracking controls, that GRPS, all the things. So considering this, our India, still we are a developing country. As Mr. Abdul Kalam sir said, 2020 we can do some developed country, but still now our aim 2030 it is behind. So we are facing such a lot of troubles and problems practically. How to identify? Have you made any case study in that, in the village side? Some in Indonesia, sir. In Indonesia, I have one information. The e-waste are they burned and they dumped in the river, and they given a biggest case study. Because of that, most of the lives are affecting. So what action we taken? Have we made such a case study, and we have to prove to the society and government that information also practically, if you help us, so it will be very warmly, it will be gently, it will be help us in a different aspect, because learning, presentation, everything is okay, sir, but it will not help us in lot of the panic situations, or what are the sacrifices are going behind every part of the world. So at least in our village, if something is happening, we have to take, sir. That's what I would like to communicate, sir. Thank you, sir.
Sir, your suggestion is well taken, sir. Actually, in my area so far, I have not encountered this kind of either e-waste or waste disposal, sir. If I came across the thing, I will take some suitable action, sir. Anyway, thanks. Your suggestion is well taken, sir.
Okay, participants. So thank you, Nirmal Kumar, sir. Dr. Nirmal Kumar, sir. You have given a very broad lecture on e-waste management. It's a very big problem now throughout the world. So disposal is a very big problem.
Okay, sir. Once again, I thank the organizers for giving me this wonderful opportunity, and also I thank the participants for having the patient hearing about this discussion. And moreover, a few answers I cannot deliver, as Arsi Kumar sir asked, few answers I cannot deliberately discuss in this forum. I think if you want to have some more answers, I think you can come on private lines, private chat you can come, sir. Anyhow, thanks for the wonderful opportunity, sir. Thank you, sir. Thank you.
Dr. Nirmal Kumar, sir. You have given a very broad lecture on e-waste management. It's a very big problem now. So for disposal, it's a very big problem, and you have using the e-waste in concrete is a very best way of this, one of the way of disposal technique. So you have done a lot of researches on this, and you presented very nicely and how to use e-waste effectively in different grades of concrete is a very useful topic. That way many professors are in the meeting now. So many of them may be doing research works, so it will be useful for them also. So by any interactions, participants, if you are having any interactions, any queries, so you can contact Dr. Nirmal Kumar sir. He's a nice person and ready to answer your questions at any time. So you can use this gentleman, Dr. Nirmal Kumar is a very intelligent person, and he has done a very, he has done a lot of research works and guiding lot of research scholars, and published more than 127 papers in international and national journals. So he is having the vast experience in academic area, that is especially in concrete technology. So you can use him effectively. Thank you, Dr. Nirmal Kumar sir, for your valuable presentation. And now we can close this session, sir. Thank you, sir. Thank you.
Thank you, sir. Thank you, sir, and welcome, sir. Sir, with your permission, can I move? With the permission, can I move out of the session, sir?
Okay, sir. You can move. Participants, please. Next session will be started exactly at 11:15. So you join the meet again before 11:15. That means 11:10. Join at 11:10. You are requested to join at 11:10. Thank you, sir. Okay, we'll meet at 11:15 now. Now the session is closed.